Hello, everyone. Welcome to today's webinar on protecting mobile shopping apps from consumers' own phones. I am John Michelson. I'm Zimperium's CTO, and I appreciate you spending the next, about 30 minutes with us. We'll get through this in 30 minutes, I imagine. Before I get launched into content, I want to make sure I give you an opportunity to ask questions along the way if you're watching us live. There is a Q&A button in the webinar software that you can use to ask a question, and it'll pop up on screen for me. Hopefully I can address general questions live as we go. I'd be happy to see questions come in as we are discussing. I'm certainly ready to stay a few minutes after the prepared material for us to cover any questions that pop in at the end. And of course, you can always follow up with us later with anything that comes to mind after. Of course, many of you will be watching this as a recorded video and you won't be able to hit a Q&A button. So you can always ask us for questions later. But let's get started. Protecting mobile shopping apps from consumers' own phones. This is ironic, isn't it? Because we put a shopping app on our customers' phones, and that very phone is dangerous to us. So we have an opportunity here. We've already been embracing the notion of using mobile to attract customers to us, to provide tremendous e-commerce capabilities in those, in both the financial world, in the e-commerce world. There is almost nothing we can't do on our phones anymore, because basically we only almost use our phones. Look at the statistics of where we're at in terms of market share of mobile devices relative to typical desktops like Windows. Also look at, this is the amazing one, right? It's almost a 10-to-1 internet bandwidth ratio between mobile devices and traditional desktop devices. When you think about it, our customers are using their mobile devices massively more than they're using their Windows desktops. So we need to, and we do, provide them a compelling e-commerce experience on their mobiles. That's all great. The problem is that obviously when you expose your application functionality to mobile devices, you risk what hackers can do to damage you. And there's obviously three different ways, there's many, but let's highlight three different ways. The first clearly is reputation. When a customer's experience is poor because of bad performance due to botnets or stolen credentials, or your app is being roboted and burning. There's any number of things that could go on. I'm going to get into some of these. Your reputation will suffer because consumers will actually attribute the bad behavior of the hacker to you, right? Clearly, what your shopping cart stewards in terms of data, your own data and that customer's own data, you have to be careful to do everything you can to protect. Because if it is stolen, obviously that's on you and the consumer. And by the way, the business takes the brunt of the financial damage, right? So there is revenue loss. There are times when credentials are stolen, or when shopping carts are full of items and credit cards are stolen, or purchases are made that were not actually the real user, they were imposters. All of that stuff happens, and when all of that turns into who pays the bill for all that, that is the provider of the shopping app. The consumer doesn't pay for it. Now, there's a bit of an irony here, if you don't mind my taking a second on this. The consumer doesn't patch their phone, doesn't make sure they operate on safe networks, doesn't bother with making sure that the apps they download are safe and not malicious. But you bear the reputation burden, you bear the issue of the theft, and you bear the financial burden associated with all of that. Frankly, bad behavior on the part of the user or of your customer. So there's something we've got to do here, right? This is happening quite a bit. I've picked a couple of airline examples just to pick an industry, but there are rampant mobile attacks on mobile apps. It's rampant. Here's just a couple. British Airways had both their web and mobile app attacked. A bunch of credit card data, passenger details and credit card information was stolen. Air Canada had the same problem. It's a significant issue, significant enough, right? Even just the credentials stolen. Here we are, Air Canada lost users' IDs and passwords. And how many of our users use the same ID and password, extremely close, or the exact same password on your shopping site? So even when you see Air Canada gets hacked, you need to immediately realize that means hackers now have your customers' credentials. And your customers' credentials means that people are going to be buying stuff and impersonating your real customers. And again, who bears the financial burden of that? You do. Does that customer realize that you were the victim? No, their reputation score of your app is going to go down because you're going to be seen as perpetrating some kind of fraudulent transaction when you are actually a victim twice, right? So this is a very important point. We see this all the time. It's very common for one site to divulge credentials that are then leveraged in other areas. So even if you are not initially targeted, the fraud that's perpetrated frequently is perpetrated on you. So how are we exposed, and where specifically? We're exposed when we deploy mobile apps and even mobile browsing capabilities into devices that we can't manage the security capabilities of. So if you think about it, we do manage the security of some pieces of this, right? Our own back office systems, we do all kinds of things with firewalls, we do all kinds of, we have a whole DMZ, and we carefully deploy and we patch our server systems and we work on all the web content filtering and all the stuff you'd want to do. Generally speaking, the internet backbone and cell communications networks are relatively safe. The problem is, we'll call it the last mile problem. The Wi-Fis that very frequently our customers operate on are insecure and easily attacked. It's very easy to go from secure to insecure communications, where communication can be intercepted and read, manipulated, etc. Of course, the device that app runs on, you can make no guarantees about the state of that device, nor the condition or the friendliness, we'll say, of the other apps that run on that device. So while your app may be even securely coded, maybe you leverage best practices, and I hope you do, clearly. And there's no comment in this 30 minutes where I'm going to tell you that your development team doesn't have a lot of work they have to do to get that app as safe as possible. Even saying that, the environment in which your app runs makes it vulnerable to attack in ways the app development team cannot defend. And this, unfortunately, is just a reality. It's not like those previous examples I just gave, or examples I'll use in the future, did not do typical best practices for secure coding and jailbreak detection and all the things that are supposedly typical. Yet, the device is attacked, your app is laid exposed, bad things happen. And that's what we've got to work on. We got to figure out how to stop that. So what does the threat look like? Let's drill down into now what happens when a device is attacked and how are they actually hit. The goal is device exploit. The goal of a hacker is, I want to steal credentials, I want to read memory, I want to log keystrokes, I want to robot your application and place transactions on the thing as if it was the real user, but it is me. That requires essentially what's called device exploit. It means the hacker takes over the phone or tablet and is able to perform functions even that we as users of our devices cannot do, right? They gain what's called root privilege and the ability to do what's called remote code execution, which means they can pretty much do anything they want. There's no pop-ups that say, hey, hacker wants access to your camera, or hey, hacker wants to send a network transaction, or hey, hacker wants to replace this legitimate app with an illegitimate app. What do you say? That doesn't happen. With device exploit, the hacker gets to do anything they want. The definition of hacking, guys, is disabling the security of something. So when the device gets hacked at the device exploit level, no security is in place anymore. Now, there are two other facets, right? D, N, and A. It's device, network, and apps. The network and browser aspect of attack is essentially the path to the device, or the way to steal credentials from a device by reading the network. If I intercept the network traffic, or if I manipulate the browser that you're on, maybe I spearfish you, etc., I'm going to get access to the device in order to exploit it. Or even just from reading network communications, I can get all that I'm looking for by stealing credentials and knowing you have a login to your shopping app. I can then use those credentials in that shopping app's URL or app in order to jump into it from my own device and do my bad deeds. And of course, apps themselves. These are the ones that when we typically do a presentation like this, people get it, right? They know. Sometimes you end up downloading apps that are malicious or leaky apps. Leaky apps are a danger too. They're not literally malicious. A hacker didn't write them specifically to exploit the device, but they abuse the permissions we give them, right? And we do this as users. We tend to say, okay, I want this cool new app. I don't want to pay for one that requires, I don't want to spend money on one. This one wants access to my this, and this. I imagine it needs it for legitimate purposes. I give it that access, and guess what? It's streaming all that data out the back door into who knows where, selling it or making it available to who knows who. And that becomes intelligence as to how to attack you, right? That's fundamentally the problem. When our customers are using your shopping app and a bad guy gets access to your shopping app's data through a leaky app, a malicious app, through the network, or by exploiting the device, you become the target. So this is the fundamental problem we have to solve, right? We're living in an environment that we can't control, and these are the facets in which we can be attacked. So what are we going to do? The fundamental, the worst problem, and then I'll get off the problem because I've spent enough time on telling us it's a bad thing and we're all upset about it. Here we go. The last point is, now that a bad guy's got control of your app, they then get into your back office. It doesn't matter that you've put up the firewalls and web content filters and all that stuff. That's why an Air Canada or a BA type attack occurred, or some of the others I'll introduce in another few minutes. When the hacker has control of your app places transactions directly into the back office systems, and the back office allows those in, even though they're actually malintent. You don't know this because it looks like your own app. The problem now is that even though you've secured your back-end systems, your app is now a weapon being used against you, and you can't even tell the difference. This was a really unfortunate reality for these guys at Tesco. Tesco had a few hundred devices where hackers had taken over those phones, a few hundred, but 9,000 customers had their accounts hacked. Because once the bad guy had control of a few hundred devices, they were able to manipulate the back-end system for thousands of accounts. All they need is access into your back-end system in a way that you can't determine is this friend or foe. And then they have a field day in your back-end systems. That's not good, right? Think about it. We expose very sensitive systems through our mobile apps. We have to. That's how we perform all the cool functionality for our customer. But in doing so, if that transaction is not secured in such a way that we know it's not a bad guy, sorry for the double negative, we get exposed in ways that in this case, £2.5 million stole from 9,000 accounts. Many of them were not mobile customers, by the way. Mobile was the way that they were attacked. Tesco was. But many of those account holders had never installed the Tesco mobile app. And yet the mobile app was the perpetrator, essentially the means by which they were perpetrated. Here's the worst part. That £2.5 million, which left the bank, they covered it. Tesco had to cover that, right? A few years later, Tesco gets hit with a $21 million fine. So the real damage, the even greater than £2.5 million is what, $5 million, rounding off, it's a little less these days, but a $21 million fine. So add that up. This is the real problem. So we've spent enough time, app-based threats are a huge mobile exposure, you get it. I'd really like to show you how this actually works. And I think that'll help give you a sense for just how this works. So we know there's a threat, we get it, and we see it. But what is it really in practice? What does it look like? So what we did was we found and opened, reverse engineered an actual sample of BankBot. BankBot is a type of malicious virus that gets buried into, it just so happens in this case, Android applications, that it's a malicious app because what happens is an app that purports to do something nice, like it's a photo editor or it's your news aggregator app or whatever, includes this BankBot functionality. And that BankBot functionality takes over your phone and attacks devices and steals credentials. And it allows hackers to place fraudulent transactions. By the way, it's called BankBot. But many of the over 600 institutions that it targets are not banks. Many of them are retail organizations. Of course, right? We always start with our business plan. We're the bad guys now, guys. And by the way, we're not the bad guys. I get it. But it makes the English easier. Here we are. We're developing the initial version of BankBot because we know that we can get into banks and do the whole Tesco thing that we just saw. We can do stuff like the Tesco thing if we just can get our virus installed into a bunch of Android phones, and then we can start making a bunch of transactions on banks. And then we realize, wait a minute, we can do this for shopping cart XYZ. We can do this for so-and-so. We can do this for this other. There you go. That's how it expanded. So what does it actually look like? This malware sits inside apps you think are fine, but in fact are not. And when those apps launch, when the target apps, your app, when it launches by the user, the BankBot virus actually takes over the phone and starts performing credentials. So the user installs, let's say, a utility app containing BankBot. BankBot monitors the phone until that target app launches. Once the target app launches, BankBot jumps on top of the screen, making it look like, to the user, they're actually running the app they clicked on. Why wouldn't they think so? They clicked on it, for goodness sakes. But in fact, they're actually staring at a BankBot screen that captures the user's credentials. Those credentials get given to the bad guy. Of course, the BankBot app has access to the same Wi-Fi's and cell towers that the rest of the phone does. So it gives those credentials to the bad guy, and it then robots the target app, or offline, bad guys can then log in themselves off another device with those credentials. And of course, equally most important, the BankBot malware actually reads the SMS traffic, the texting, right? Texting is SMS. It consumes those SMS messages so that even if you're on that other device, and even if you want one of those really smart shopping apps that makes a user type in a 4-digit or a 6-digit two-factor authentication code, well, that's great, but the bad guys got your two-factor authentication code. So they read those SMSs, and here's what it actually looks like. So here's a demonstration where the good guy, the victim, is on the left. The bad guy is the screen at the bottom and on the right. The guy on the right is a bad guy somewhere else in the world who's about to steal credentials and use them. And this is a video, so I hope in our webinar you see it. You don't realize this, but that's the BankBot. The screen flickered briefly. I launched my actual banking app and BankBot jumped on top. I just logged into what I thought was the actual bank's app, but it's not. And I just got a two-factor authentication code, which I will type in. Notice what's happening at the bottom. The bad guy's getting everything I type. The bad guy gets the SMS code too. So now I'm looking at the bank, right? And that's great. But so is a bad guy. A bad guy is about to log into the same bank. But wait, we need our two-factor authentication code. There it is. The mobile device gets the code, gives it to the hacker, and now the bad guy's logged into the app just like the good guy is. Now, that's the fundamental problem. This is how these types of attacks occur. This is not a one-off. This is happening on millions of devices. There are tens of millions of dollars leaving banks and financial institutions and shopping carts and everything. Every kind of commerce that can be done on mobile every year. We know, by the way, per RSA and threat metrics, that more than 50% of all fraudulent transactions are mobile-based, not coming from traditional desktops anymore. So this is actually now commonplace. So when the hacker takes over the device, they get anything they want. Your so-called secure messages, and we're actually looking at a disclosure we made some time ago on a so-called secure messaging app called Telegram. The so-called secure messages can be read even if it's in memory or on disk. There they are. These guys worked very hard to secure all this and encrypt it. All right, so much so, by the way, that Russia bans this app. That's kind of cool, right? I'd be pretty pleased, right? That I thought I'd done a pretty good job of my messaging app if Russia bans the use of the app. And yet, compromising that device exploit thing I just mentioned a minute ago exposes those messages to the hacker really easily, easier than you thought. So this is the way you get attacked. And these are ways, that BankBot example, this particular example, These are things you can't have your developers just say, hey, by the way, let's put it on the backlog of things we want the developers to do. Make it so that BankBot doesn't work, or make it so that the hacker can't read the memory and decrypt our encrypted transactions on disk or in memory. That doesn't work. You need sophisticated detection technology in order to make that work. That's where we come in. So I think, overeducated you on what hackers do. Don't be too impressed, or at least try not to be. It actually is clever. I hate it that it's clever, right? What they do is sophisticated. What we do to detect them and defend you is more sophisticated, which is cool, right? So we've invented a detection engine we call Z9. Z9 is able to detect real-time on-device whenever any of those types of attacks are coming onto your app, or even the device itself or the network. So when that device exploit is attempted, or when a bad guy takes over the network or tries to spearfish a particular user or in a browser, or of course a malicious app is resident on the phone already and lying in wait to attack you the way we just demonstrated BankBot. Our engine is able to detect those conditions and warn your app that it's under attack. Isn't that cool? That's in fact how you'd be able to defend yourself. It takes a very interesting set of technology in order to do that. We happen to use machine learning to do this because frankly, the architecture associated with mobile devices is quite different than that of traditional networks or desktop devices. We can't install drivers into the operating system. We run in a sandbox just like your app and just like the rest of the world, the rest of the world's apps. You'd have to be malicious in order to have special privileges, which obviously we aren't going to do. So it takes actually fairly sophisticated machine learning tech in order for us to do this. But the good news is we've done it and we can put it inside your app. Now we do this in two ways, right? One way is we protect companies and the company's devices. Think of this as your mobile endpoint, right? You've got desktop endpoints and you've got mobile endpoints. Pardon me. Your mobile endpoints need our app called Zips running on your phones so that you guys don't get attacked directly. We've heard this constantly, right? Somebody broke into so-and-so company, stole a whole bunch of passwords, stole a whole bunch of credit card information, and did so by attacking their back-end systems. Well, by the way, how'd they get to their back-end systems? Well, 90% of the time, they're using stolen credentials. Well, how did they steal the credentials? Well, we don't always know that, do we? But I'll submit to you, the easiest way for hackers to steal credentials today is on a mobile device. And I'll win that argument every single time. Unless, of course, we have fools sending it out as emails. We've seen that, right? If you guys have done any amount of discipline around securing your workforce, right, reasonably best practices, the mobile device is the easiest way to steal credentials. So you need an app like Zips, which has that Z9 engine inside of it to protect the whole device so that your company is safe. But the topic of this webinar is not that. I wanted to make sure you had that as a parenthetical or a little short digression. The real point is we can embed inside your apps. So we have an engine we call ZApp. ZApp is an SDK that goes into your app and that protects your app. Because now, instead of the slide before where we showed X's and an exclamation point on the last mile, our engine, Z9, can detect and make sure you are aware and able to defend yourself if the Wi-Fi goes bad on you, if the device gets exploited, if other apps are too leaky or malicious. And that means your app goes from unsafe to safe. That's the fundamental point. The network attacks, the device level attacks, or the app-based attacks are now defended. And your app is no longer going to leak. Sensitive data is no longer going to be credential stolen, is no longer going to have transactions posted into your backend system that were not that were fraudulent in nature. So here's an example of this. When you embed our ZApp, here's a Coinomi, this is a Bitcoin wallet, by the way, a Bitcoin wallet. And so of course, anyone who has the keys has the money. Bitcoin is just like cash in that it's literally represented as a string of digits. The string of digits are the money. If I get your string of digits, your Bitcoin key, and I use that on a Bitcoin service, the money is spent. When you go later and try to spend that same coin, it's going to be shown as already spent. So whoever has the coin has the money. So here we are on a phone. We create a wallet. We presumably put a bunch of money into that wallet. A hacker goes and hacks that phone. And if the hacker gets access to those coins before you spend them, that money is gone. But if our engine is embedded inside that app, you get notified when that bad thing occurred, and you're able to defend yourself. In this case, defending yourself means removing those keys from the mobile device. Make the user re-log in. Tell the user, your phone's been attacked. We shouldn't have Bitcoin sitting in the clear for a hacker to go steal. So I've removed it from this mobile device. And by the way, you can restore it once the system is, or once the system's clean. I'll let you restore that wallet by re-logging into our cloud service, and you can download your keys again. But you can't have these keys in the hacker's scope or visibility so long as the hacker's there. Ta-da, we've protected the Bitcoin. The same kind of use case maybe for you guys, whatever your particular situation. Once you have the ability to see when you're being attacked, you have the ability to defend yourself, however that defense occurs. Without it, the types of attacks that will be perpetrated on you and that are being perpetrated on you, if you have any sizable install base, I assure you, this is already happening. They're stealing data from your app. They're logging your keystrokes. They're hijacking your network connections. They're reading your app's memory and files. It doesn't matter if you're encrypting it. It doesn't stop the hacker. The best you can do is slow it down. And you're jeopardizing your user's privacy. That PCI data, that HIPAA data, that whatever, that private information that you contain, that you asked the user for, that you downloaded from your secure servers, is now in the scope or visible to a bad guy. And obviously you have a responsibility there. So our engine embedded in your app enables you to protect that data in a way that you can't right now. And that's what ZApp does for you. So those are the two ways you use us. You use us inside your apps so that when the consumer is using your app, you're protected. And you can deploy us as an app ourselves to protect your own phones and tablets so that they can't get in and steal that credit card information or that sensitive patient data or customer data that way either. So let's go back to the BankBot. Only now our banking app has our engine built into it, right? And when the hacker attempts to steal, by the way, we're not going to see a hacker screen because frankly, the hacker doesn't get anything anymore. You're now seeing our console on the right-hand side, our console being the Zimperium ZApp console. So now your app is going to be launched, and the instant that it's identified that there's a bad guy operating on this device, you clearly get told, wait a minute, your app is under attack. Don't log in. In fact, we need you to reset your password just in case somehow you've already been attacked. And here on the right-hand side, you guys get the visibility to, by the way, we protected a potential fraudulent set of transactions from occurring because we detected BankBot was embedded inside of an app on a phone. We triggered a detection inside the app, which means that you protected the app and the user in the process and your backend systems. And of course, we collect forensic information on who the bad guy was and how they tried to get after you that you can use, integrate with other potential attack scenarios maybe you're dealing with, or obviously just have the knowledge that you've protected yourself from potential fraud. So we just turned, what was that, a 1.5 minute long video before where we were watching a hacker log into a victim's account. We turned that into, instead of 1.5 minutes, 3 seconds long worth of video. The app launches, the app starts our engine detects it's unsafe, tells us not to allow this login until the user removes that malicious app, and informed our backend system that that was occurring. Voila. Disaster averted, problem solved, fraud line comes down, happier customers, better reputation, less theft, less financial risk. So that's what we're trying to accomplish for you guys, and I hope that you see how we can do that for you. So we've done this. We're already on millions of devices. I'll go very quickly through a scenario where here's, again, a banking example. Since as far as we can tell, some of the biggest exposure to fraud is in banking and in shopping apps, which is why we've done a specific webinar for both banking customers and now, obviously, with you guys here in retail. So we've been on enough devices and with enough large customers that we see what this threat really looks like. We're not giving you guys theoreticals. We're giving you live, actual data. Here's a bank example where we're protecting the transactions upwards of $1 billion. And there's a ton of threat data these guys are now getting visibility to because we're embedded inside their app. Many of the attacks and many of the risk conditions that they are experiencing are device level attacks. Remember I said, the device level attack exploit is the goal of the hacker. The means or the path to the device attack is either an app or a network threat. But they're trying to get at you at the device level in order to perform these types of transactions like the BankBot example I showed earlier. So that's really happening. This is live, real data from a real customer who's on millions of phones. So we know this is happening. So here we go. Summarize, sales pitch, warning. We're deployed to millions of devices already. We're fairly easy and rapid to implement. I say fairly because nothing is simple in the mobile world and in the app world. Your dev team needs to take our SDK and embed it. It's actually super simple, but they still have work to do, and it's legitimate work, so it's easy enough. We provide you passive, non-intrusive detection. By that I mean we're not changing your user's experience. We're not making this whole huge additional work on your development team. It's not a lot of work. We're a minimal footprint. Your app isn't going to all of a sudden slow down. We have no performance degradation. You don't even know we're there. You really don't. In fact, being on, I think it's tens of millions of devices in the US alone, within this webinar, there's a likelihood at least a few of you are already running our code buried inside your, not your own app, obviously, well, unless you're already a customer. Thank you, hi. But if you're not, you probably still have an app that is using us embedded inside, and you don't know the difference, right? That's the best comment I could make, and maybe summarize a few of these icons. You're probably running our detection engine inside an app already on your phone that's protecting you and that e-commerce retailer, that payment processor, that bank, whoever, because those are the types of folks who are our customers already. But you don't even know it because it's non-intrusive. It didn't bloat the app in a way. We don't pop up these weird screens. So you'll be fine with it when you embed it in your own app. We deliver forensic data to your own DevSecOps teams, your security teams, your development groups, et cetera. And very important, there are simple steps we take automatically to protect you. But again, we enable customized in-app remediation. I usually use the word defense instead of remediation, same thing. You can remediate the threat when we trigger that detection inside your app. A good example is reset the user's password, make them relog in again once the malware is off the phone, as an example. Another might be, we're not going to allow transactions greater than a certain amount, or we're not going to allow you to create a new address in your phone, in your address book to send these goods to a different address. We're only, if we think the device might be compromised, we're not going to allow you to ship to anybody but your own existing addresses. Just real simple stuff like that allows for safer e-commerce on your part. You've avoided risk and threat that way. All right, so the potential damage resulting from attacks is significant, and they can occur across every app on the phone. Even not your app can be attacked, another app can be attacked, and then those credentials can be used on your app. It's a really dangerous aspect, right? So your user's devices are vulnerable, and the way to protect yourself is ZApp. It's our SDK, it's proven, and it's been implemented inside of millions of phones already, probably on a couple of yours. And the neatest part is ZApp takes less time to implement for your dev team than it did for me to complete this presentation, which I might add is just barely over 30 minutes, so I mostly met my goal of getting through in a 30-minute presentation. So I have one last thing to offer, and then I'll remind you about the Q&A if you want me to hang out for another minute or so. You or your dev team, if you happen to be in the dev team, you can go and create your own account and download our SDK and try it in your app right now without ever making a phone call or having to get a hold of us. You literally go to zapp.zimperium.com/signup or go to our main website and click through to find that. You'll be able to create an account with nothing more than an email address. We don't need a credit card to get you started. We don't need anything else. And you can download our SDK and our docs and our sample code, our sample apps. By the way, that Coinomi app I showed you, we actually give you source code to that so that you can actually see how we implemented it there. You can try it out for yourself and see what kinds of things we can do. It even includes, by the way, since many of us don't know how to attack our phones, right? We're not bad guys and we don't do this. We include a little kit that allows you to simulate attacks on a device that's running your app so that you can actually see how our engine works, how it detects the threat, how it triggers your ability to defend it, that remediation logic, and makes that whole thing work pretty easy for you. So if you're interested, you can go and grab that. Otherwise, I think my work here is done, and I really appreciate your attention for this half hour. If you have any questions right now, I will hang on for another minute or so. If not, have a great day, and I hope you enjoyed the presentation. Thank you.